So limit states. Limit states define the failure mode and the capacity of footing corresponding to each limit state is determined from the mechanism of failure. So limit states define the failure mode and capacity of the footing corresponding to each failure mode or each limit state can be determined by using the mechanism of failure. So based on the failure type we can calculate we can find out the capacity of the footing. So while designing the footing, all types of failure modes need to be investigated and safety is ensured at service load. So let's see what are the limit states in case of concrete footings and what are the design consideration corresponding to those limit states. So first one is soil failure or differential settlement. Our foundation can fail either because of failure in the soil. Soil can fail in shear, or there can be excessive settlement, or there can be differential settlements. So because of the differential settlement, our structure or our foundation can fail. Okay, to avoid this type of failure, we need to play with the size and type of footing. So we can change the size to avoid the soil failure, as well as we need to change the type, or we need to properly select the type of footing to avoid the differential settlements. The next possible failure is one-way shear failure in case of footing. So to avoid the one-way shear failure, we can play with the thickness of the footing slab, thickness of the footing slab. So to increase the capacity against the shear failure or one-way shear failure, we need to increase the thickness of footing. The third failure mode is two-way or punching shear failure. So again, to avoid this type of failure, we can play with the thickness of footing. Flexural failure or failure due to bending. So to avoid this type of failure, we can play with the thickness of the footing, as well as we need to design the reinforcement for footing slab. The fifth type of possible failure is bearing failure at the base of the column. So this can be avoided by dowel reinforcement, by providing dowel reinforcement, or by increasing the strength of the concrete in column. The sixth type of possible failure is bearing failure in the footing slab. So this can be overcome by providing the dowel reinforcement. And the seventh type of possible failure is slippage in the dowel bars or column reinforcement. To ensure the safety against this slippage, or to avoid the slippage, we need to provide the minimum development length.